Welcome everyone. Let's discuss one of the question of GATE 2023 Biotech exam. The question says, a deoxyribose nucleoside triphosphate master mix is prepared by combining 40 microliter of each 20 millimolar dNTP stock, which is dATP, dCTP, dGTP, and dTTP. 4 microliter of this dNTP master mix is added to a PCR mix, and final volume is adjusted to 50 microliter. And then we need to figure it out, the concentration of the total dNTPs in the PCR mix. So as we all are aware, while setting up a PCR reaction, the different components which are added to the tube are template DNA, forward and reverse primers, thermostable DNA polymerase, assay buffer, and dNTPs. However, it is mentioned in the question that instead of adding 4 dNTPs directly to this PCR mix, a dNTP master mix was created, where in a single tube, a particular volume of a particular concentration, all these 4 dNTPs were added. And then from this tube, a particular volume was taken and added to this PCR mixed tube. And what we need to do, we need to calculate the final concentration of the dNTPs in this PCR mixed tube. This is a very common practice. Instead of adding all the 4 dNTPs individually into the PCR mix, a dNTPs master mix is created, and from that tube, a particular concentration is added. Before solving, let's discuss few of the terms. How do we define concentration? It's an amount of a solute dissolved in a given volume. There are different ways we measure the concentration. Molarity is one of them. And we describe molarity as moles of solute by volume of solution in liters. I can also rewrite molarity as micromole per microliter. Remember, 1 mole is equal to 10 raised to power 6 micromole, and 1 liter is equal to 10 raised to power 6 microliter. So this will give me the micromole per microliter. Why I have converted into this form? Because there are many terms in this question, which is in a form of micromole and microliter. So let's read this question once again and try to solve it. So we need to find out the concentration of the total dNTP in the PCR mix. So as I have said it just now, there are 2 tubes, PCR mix and dNTPs master mix. And I need to calculate the final concentration of the dNTPs in this particular tube PCR mix. So first I need to calculate the concentration of all the dNTPs in this tube, and then we can calculate the final concentration in the PCR mix. Because remember, what is given is for the individual dNTPs. First, we need to calculate the final concentration of all those 4 dNTPs, which is dATP, dCTP, dGTP, and dTTP in a particular tube. So if I have to calculate the concentration of the dNTPs in the master mix, remember, I can make use of a formula, molarity equal to micromole per microliter. However, remember, the values are given for a single dNTP. So what I need to do, first I need to calculate micromole for each, and then I need to calculate the molarity. So if I have to calculate the amount of each dNTP, remember, don't get confused when I'm saying amount. When I'm saying amount, that means in a form of a mole or a micromole. So amount of each dNTP in micromole, I can calculate by multiplying the concentration with the volume. It's a microliter. So amount of each dNTP, I can multiply the concentration of a single dNTP, which is given 20 millimolar, which I can convert it into a molar. So 20 millimolar corresponds to 20 into 10 raised to power minus 3 molar. 1 molar is equal to 1000 millimolar, or 1 millimolar is equal to 10 raised to power minus 3 molar. So 20 into 10 raised to power minus 3 molar into 40 microliter, and this will give me the amount of a single dNTP, which is going to be 0.8 micromole. So amount or micromole of each dNTP is 0.8 micromole. Remember, there are 4 dNTPs, A, T, G, C. So this is going to be 3.2 micromole. This is amount. I need to calculate the concentration. So I have calculated the numerator part. So if I have to calculate, let's say, molarity, which is moles, which I can rewrite as a 3.2 micromole per microliter. How much is the volume? Remember, for each dNTPs, I'm adding 40. So the total volume is going to be 160 microliter, and the value is going to be 0.02 molar. So the concentration of all the 4 dNTPs in the dNTPs master mix is 0.02 molar. But this is not the final answer, because I'm taking a 4 microliter. If I'm correct, I'm taking a 4 microliter of this dNTP master mix, and I'm adding to this PCR mix, and I need to calculate the final concentration in this particular tube. So when I'm taking a 4 microliter from the dNTP's master mix, how much amount I'm taking, so that I can calculate same way. As I said, molarity, you can calculate it by micromole per microliter. So it's given 4 microliter of this dNTP master mix is taken. So 4 microliter into 0.02 molar, and this is going to give you 0.08 micromole. This is amount. Now I need to calculate the final concentration in a PCR mix tube. And how am I going to calculate it? As said, molarity is equal to micromole by microliter. Micromole we have calculated, which is amount 0.08, and the total final volume is 50 microliter. Have a look here. And the final volume of this tube and the final volume of I'm talking about this tube. Final volume of the PCR mix tube is 50 microliters. So what I'll do is, in the denominator, I'll keep 50 microliter. It's a simple calculation, and this will come out to be 1.6 into 10 raised to power minus 3 molar. We need to mention our answer in a micromolar. Remember, 1 molar is equal to 10 raised to power 6 micromolar. So 1.6 into 10 raised to power minus 3 into 10 raised to power 6, which is going to be 1.6 into 10 raised to power 3, or 1600 micromolar. So your final answer is going to be 1600 micromolar, because that's the same thing they have asked. 1600 micromolar. I hope this solution is clear to each and every one of you. If you have any doubt, feel free to comment in the comment section. Thanks for watching the video.